S. Chan presents educational video lectures as per the new UGC CBCS curriculum. Absolutely free. Difficult concepts made easy. Study anywhere, anytime.
Hello everyone, in this lecture we will be learning basic theory of differential equations. What does it mean? It means we will be just learning order, degree of an differential equation, then what type of solutions we get, what type of differential equations we have, and types of solutions. It means linearly independent solutions, dependent solutions. All this we will be learning in this lecture. Hello everyone, I am Dr. Seema Thakran. Welcome to S. Chand Academy. If you want to study this topic, basic theory of differential equations in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box. So let's start with the topic basic theory of differential equations. Basic theory of differential equations. First, I will give you the main or general equation of a differential equation. So, general equation of a differential equation, it is always of the form x, y and dy by dx. This is very, in interviews also it is asked, in competitive exams also you are asked. What is basically a general differential equation. So, this is x you will have, y you will have, and y will be function of x, because dy by dx you are the rate of change of y you are considering with respect to x. So, y will be function of x only. This is general equation of differential equation. Now, I am just writing few 2-3 equations and I will tell you how to judge order and degree, because after that the important point is order and degree of a differential equation. I am writing few differential equations. So, 2 dy by d square by 2y then d cube dx cube x dy by dx dy by dx whole power 5. Now, with the help of these examples, you will be able to learn what order, degree. 4 terms I will be explaining: order, degree, linear, non-linear. How to check order of a differential equation, how to check degree, linear, non-linear. So, order means highest derivative. Order means highest derivative. Degree means highest derivative power. Linear means there is no multiplication with the y of the derivative. Non-linear means if you have degree more than 1 and derivative multiplication with y, or y power is more than 1. So, this is how you figure out what is the degree in order, linear and non-linear. I will start with first example. In first example, what is the highest derivative? That is 2. It means the order is 2. What is the highest derivative degree? That is 3. So, it means degree is 3 for first case. Now, whether this is linear or non-linear, you can see the degree is not 1, it means this is non-linear. So, the first one is non-linear because the degree should be 1. Now, moving to the second equation, this is highest derivative is 2, highest derivative power is 1. Linear and non-linear, you can see the derivative is 2 but the degree is 1. So, this is linear. Now, moving to the third one is, you can see the highest derivative is 2 and multiplication is with y, the derivative multiplication is with respect to y. So, it means third one is non-linear. Now, the last one is, you can see the highest derivative is 3, highest derivative power is 1. Anyhow, the 5 power also you see, but this is not highest derivative. So, highest derivative is 3 and highest derivative power is 1. Now, this is linear case. You can see there is no y, y power is 1 and degree is also 1. So, this is also linear case. This is how you check linear order, degree, linear and non-linearity of a differential equation. This is very, very important point, because you are asked in interviews, competitive exams. Now, moving to solutions of a differential equations. So, I am writing now solutions, type of solutions. Solutions of a differential equation. What type of solution? One is general solution, another is particular solution. How we find solution, that we will be learning in coming lectures, but type of solutions we should be knowing ki what type of solutions you have for a differential equation. So, general solution means number of constants in the solution equal to the order of the differential equation. यानी जितना order है, 2 order है तो 2 constants आपके general solution में होते हैं, तो उसको आप general, अगर 2 order है और 2 ही constants है, आप उसको general solution बोलते हो. Particular में you assign some particular value to the, according to the question ही आप उसमें mention करते हो, particular values to the constants in general solution. So, ये 2 type के solutions हैं. There are other ways also, but for your course this is required. Now, moving to solutions, you got to know, but if you have a solution, how you check the linear independence and dependence of the solutions. So, let y is equal to sin x is y is equal to sin x and y1 I should consider, y2 is equal to cos x be 2 solutions of, as I told you, solution finding we will be doing in the coming lectures. I am saying कि these 2 solutions are solutions of this differential equation. You can check also. How to check? Then I will check the linear independence and dependence. What to do? If this is solution of this equation, it means this is satisfying this equation. So, y1 is sin x differentiated. So, this will give you, second derivative will be cos x. What will be the solution? y2. Second derivative will be, so this is y1 derivative with respect to x, this is y2 derivative, so this is minus sin x. Now, y2 derivative is minus sin x and y2 double derivative is, just wait for a while, this is y1, then this is y1 ka first derivative, then y1 ka second derivative, then same here y2 ka second derivative will be minus cos x. So, and if we go by the method, the solution of this differential equation is y is equal to c1 cos x c2 sin x. It means if this is solution, then linear combination will also be solution, and you can now, if you merge both, you can see the this equation will be this y is equal to will be solution of this equation, and how we find we'll be doing in the coming lectures. This I just told you. So this is solution. Now y1 equal to sin x and y2 equal to sin x, linear independence and dependence. How you will be checking? Your y1 is sin x, y2 is cos x. I am just telling you the general definitions right now. So if you have two solutions, if they are linearly independent, so if these solutions are linearly independent, then this combination, this linear combination of the two equal to 0 will imply दोनों के जो दोनों constants हैं वो दोनों 0 आएंगे अगर आपके पास linear independence है. अगर linear independence नहीं है, linear if the solutions are linearly dependent, this is short form for linear independence and linear dependence. If solutions are linearly dependent, then क्या होगा आपके पास, आप ये consider करोगे linear combination, this is linear combination, and either of CI's, any one of the constants will be non-zero. एक constant 100% non-zero होगा, any of the constants C1 और C2 या दोनों ही will be non-zero. Either any one और कोई भी एक जो दोनों में से non-zero होगा. So this is linear dependence and independence definition. Now moving to, okay, what we left to show that this is solution of, and just change the differential equation. This is basically y. Now I told you that y is equal to sin x, y2 is equal to cos x, d2y by dx square plus y. Now you can easily see y was sin x ना. सो जब आप इस यहाँ पे सेकेंड डेरिवेटिव माइनस साइन एक्स आ रहा है और y की वैल्यू है साइन एक्स, आप देख रहे हो इजीली कि ये 0 बन रही है वैल्यू. सो इट मीन्स दिस इज सोल्यूशन. सो माइनस साइन एक्स प्लस साइन एक्स बिकम्स 0, इट मीन्स साइन एक्स इज सोल्यूशन ऑफ दिस. देन y2 डैश माइनस कॉस एक्स आ रहा है और y2 कॉस एक्स था, तो आप y2 को जब यहाँ सब्सटीट्यूट करोगे इट इज अगेन गिविंग यू दैट दिस इज सोल्यूशन. सो दोनों सॉल्यूशंस हैं, लीनियर कॉम्बिनेशन भी सॉल्यूशन होता है. और सॉल्यूशंस कैसे फाइंड करते हैं, विल बी डूइंग इट इन कमिंग लेक्चर्स. लीनियर इंडिपेंडेंस डिपेंडेंस कैसे चेक करते हैं, दैट ऑल्सो आई हैव शोन यू बाय लीनियर टेकिंग द लीनियर कॉम्बिनेशंस. सो टिल नाउ वी हैव लर्न द डिफरेंशियल इक्वेशन, बेसिक डिफरेंशियल इक्वेशंस, सॉल्यूशंस, solutions linear independence, solutions linear dependence. Then one more thing was general solution. What is general solution of a differential equation, particular solution of a differential equation. After this, an order degree, linear and non-linearity also we have discussed. After the break, we will be just few more concepts we will be learning for differential equations.
वेलकम टू यूट्यूब चैनल ऑफ एस चांद अकेडमी. मैं हूं आदित्य और आप लगातार मेरे साथ सीख रहे हैं जूलॉजी को. अब तक के पिछले वीडियोस में हम जूलॉजी फर्स्ट सेमेस्टर और सेकंड सेमेस्टर के सिलेबस के हाइलाइट्स कवर कर चुके हैं. उन वीडियोस में हमने फर्स्ट सेमेस्टर के पूरे सिलेबस में टेक्सोनॉमी के बारे में डिस्कस किया था. सेकंड सेमेस्टर के सिलेबस में हमने कंपैरेटिव एनाटॉमी और डेवलपमेंटल बायोलॉजी की बात की थी. जल्दी ही आपको मिलेंगे थर्ड सेमेस्टर के वीडियोस जिसमें आप समझ पाएंगे फिजियोलॉजी और बायोकेमिस्ट्री को. फिजियोलॉजी और बायोकेमिस्ट्री एक दूसरे से बहुत कनेक्टेड जुड़े हुए सब्जेक्ट हैं और आपके सिलेबस में कुछ इंपॉर्टेंट फिजियोलॉजिकल सिस्टम्स की बायोकेमिस्ट्री एज वेल एज बेसिक मेटाबॉलिज्म की बात की गई है. उन सारे वीडियोस को हम आने वाले सीरीज़ में देखेंगे. कीप वॉचिंग, डू सब्सक्राइब एंड शेयर टू दिस चैनल.
Hello everyone, welcome back to S Chand Academy. So before going to the break, we have learned few basics of linear differential equations. Now I will be explaining you what are homogeneous and non-homogeneous linear differential equations. So homogeneous and non-homogeneous linear differential equations. Linear differential equations. Suppose you have an equation and the RHS function, on RHS you have 0, then you say that the differential equation is homogeneous. And suppose you have function or your equation of the type this. It means this time you don't have any 0 on the RHS. This is example of non-homolinear differential equation. So on RHS, if you have 0, that is homogeneous equation, and we have different methods for homogeneous linear differential equations for solutions, and for non-homogeneous also we have different methods. But on RHS, if there is some function, then you say that is the equation is non-homogeneous. If 0, then you say homogeneous. Coming to now, before the break I took one example, and the example was this. The two solutions of this equation are cos x and sin x. Before the break I gave you different linear independence, one definition that is anyhow difficult also, or sometimes it is very difficult to check by that equation the linear independence and dependence. So now easy checking for linear independence, and what exactly that is, we call it Wronskian. So let's start with Wronskian, and in the before break I told you our linear combination definition for checking linear independence and dependence, but now Wronskian is anyhow easy to check the linear dependence and independence of two solutions. So suppose you have two solutions and they are y1 and y2. So the Wronskian, how we write the Wronskian for the two solutions? First row, this will be a determinant 2 by 2, if two solutions 2 by 2 are Wronskian. Then in the second row you will write the derivatives with respect to x. If it is non-zero, the solutions will be linearly independent. So this is important, that if non-zero then linearly independent, and if Wronskian is 0, in that case it will be dependent. The solutions will be linearly dependent. Now what if there are 3 solutions, because if the order will be 3, it means you will get 3 solutions. In that case, how you will be writing the Wronskian? So suppose y1, y2, y3 are 3 solutions of our differential equation, then the Wronskian determinant is easy to calculate for solutions. The Wronskian will be y1, y2, y3. First row will be y1, y2, y3. Second row will be the first derivatives of 3 solutions. Then second will be second derivative of all the 3. So this will be a 3 cross 3 determinant matrix, and if you want to know linear independence, so it should be non-zero. For linear independence, Li I am writing in short, and if it is 0, the Wronskian is 0, then linear dependence, the solutions will be linear dependent. Now suppose if you have 4 solutions, that is the max case for your course. What if the 4 solutions you have? So suppose you have y1, y2, y3 and y4. So it means it will be a 4 cross 4 matrix, because in your 12th class you do the determinants till your till 4th order. So in first row all the solutions, second row first derivatives, second row second derivatives of all the solutions, and third row it will be third derivatives. So this is how you keep taking the derivatives, and accordingly you will get your matrix. So it means if and how you, this is difficult to check because 3 cross 3 determinant you know how you will be, if such a case, big case you are getting, then row operations you will be applying, column operations you will be applying. First you will simplify this matrix and then only you will be opening the determinant by with respect to first row, second row, third row or fourth row. Methods you have already learned in your 12th class. So this is how you have to reduce this matrix. Directly you cannot calculate the determinant, and this is the max case. Anyhow 3 by 3 is the highest order. So if this is non-zero, linearly independence, and if it is 0, the linear dependence relation between the vectors. So these are the basics for linear differential equations. What basically we have learned: homogeneous linear differential equations, non-homogeneous linear differential equations, types of solutions, order, degree, linearity, non-linearity of differential equations, and the linear independence by two formulas. One was by the help of linear combinations, taking the linear combination of functions. Then if constants you are getting as 0, then linear independence. If any of the constant is non-zero or all are non-zero, then linear dependence. Then Wronskian method, Wronskian property is that if it is non-zero, then linear independence, if it is 0, linear dependence. So this all we have done in this lecture. If you want to study basic theory of linear differential equations, please refer to the book by S. Chand Publishing. The e-book link is given in the description box. Don't forget to share, like and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.